Hello, I'm Rajat. Welcome back to the channel. We are here with another video. We will be solving today, I suppose, two questions on lead code. Both are easy. I'm solving easy questions first, and then we will move on to medium level questions. So the first question that I'm choosing today is number of one bits. Well, the one bits, as you can know, let me just open Paint. Yeah, any number or any character, because computer understands binary digits, that is 0 and 1. So any number that you type in into your system, they get converted into either ones or zeros, right? Either ones or zeros. We can see 1, 1, 0, 1, and so on, right? And these are and out of those binary bits, the ones are actually called as the set bits, and not these. Okay, red. And the zero bits that you're looking at are called as the off bits. These are on, these are off. So this is how binary thing works. So here in the question, it is said that given an integer, positive integer, write a function that returns the number of set bits in its binary representation, also known as the Hamming weight. The number of set bits in a binary, in a number, is called as the set bits. So how are you going to do it? Let's move back to our old friend MS Paint. So what I will do is that suppose I'm given a number, say 4, right? How does 4? Okay, let's just take a random number. I'm not talking. Let's just take the same number, 10110. Okay, so we have something called as the AND operator in the bit manipulation. If you have studied, we have called as the AND operator, and AND operator works as 1 and 1 is equal to 1. This is AND operators, not 8. So this is AND operator. Let's just, yeah, this is AND operator. And also, one more thing that we will take advantage of is that 1 and 0 is equal to 0. So this is how a normal AND works in programming. And also we have 0 and 0 is equal to 1. If both are false, then it's true. If any one of those is false, then it's false. Okay. So if both have the same value, then it's true. Otherwise, it's false. That's a simple truth table for an AND operator. So we will take the leverage. We'll leverage this. Sorry, we'll take the advantage of this thing here. Okay, and also this thing. What we basically do is that what we will basically do is we will just add 1 and count what's is given here. I will get 0. So I won't count it. Let's see with the counter. Okay. And we'll see it. And once that has happened, what we will do is we will left shift the whole number. And by left shift, I mean that I left shift one time. So the whole number will get shifted to the left for one time, and the number will become 0, 1, 0, 1, 1. That's how it is. Okay. Then I will again do 1, and we will get 1, and we will add this up to counter, so on. And I will do again left shift is represented this, and I will again let's just increase this again. Yeah, so I will again left shift and it will become 0, 0, 1, 0, 1. And I will do AND operation again to 1, and since it's 1, the counter increases by 1 and becomes 2, and again another left shift and become 1, 0, and I do AND operation again and I get 0. So the counter doesn't change. Yeah, can we increase it more? I suppose. Let's just okay. So what I will do here is that I will just left shift the whole number again, and it will become 2, 0, 4, 0, 1, and I will perform an AND operation here, and it becomes 1 again, and this counter increases to 3, and again I do one final left shift until the whole number becomes the uh, initial number becomes 0. So this has become 0. This has become 0. So I stop the iteration, and finally my count is C is equal to 3. So I have 3 set bits in the whole number, whatever this number is. I just took it as an example, but whatever, this is the algorithm, and this is how the algorithm works. So we will write an optimal approach. Basically, the bit manipulation approach is the most optimal approach. But what we can do directly here is that we can add C plus. Okay, what we can basically do is we have a counter C, and we can just do the num and 1 while the number is greater than 0. This will simply just uh, add 1 to the whole operation to the counter whenever the last bit is set. Okay, so we'll do it right. So let's go to our operators. Let's do it. So what we will do here is that we have n. Let's take counter is equal to 0, while n is greater than 0. We'll simply counter plus n 1. Remember, this is the AND operation. Yeah. The brackets are optional, but I'm just writing it to segregate the whole logic. And don't forget to left shift it by 1. Okay, so this is how the left shift operator works. The number of left shift that you want to perform is written here, and the number on which you want to left shift is written here. So I'm left shifting the whole number n for one time. Okay, so it will just work in the logic, and at the end I want to return counter. That's it, and it should work perfectly. Yes, this will run faster in C++. We will also write it there. You can see 100%. Okay. There might be any function here to check the Hamming weight in Python. Let's see it. If excuse me, it's a better way. Okay, k is equal to result. Both are initialized to 0, and while who's okay. This is a solution from William H. Big shout out to him. Just reading out the solution. If I understand, then it's good. This is the key, 2k. Okay, 2 to the power k is less than n. Okay, I don't understand the solution. I'm supposed to conversion. This is okay. I actually don't understand. It's very optimal, I suppose. There's no while loop here, so no, there's a while loop. There's a while loop. So I suppose it's optimal, but hey, let's okay, let's do it in C++ as well. I have in counter, which is 0, and while and counter plus n 1 and n is equal to n left shift 1. Okay, and here we see the effect of choosing Python. Return counter. I am forgetting about the semicolons. This is a very simple logic. It's nothing to be like complex here, and it's 100%. Okay, so that was the first problem for today. And let's check out if okay. So there was also another problem that I wanted to solve yesterday actually. That's the like traversal of the N-ary. If it's still here, okay. Should we try reverse width? Question number 190. Hmm, we can actually, but I want to try that in array. So let's see if there should be like similar questions. An array post order traversal, yes. Binary or a tree in order traversal, I think I have completed it already. Uh, it isn't completed here. Binary tree in order traversal, but I think I have completed in Python. No, let's do it. It's nothing to be afraid of. Let's just go and call it def. It's just simple. If you haven't watched the post-order and pre-order traversal, I will give a link somewhere in the video. You can click and watch it. It's just yesterday's video, so you can just watch it. But in order traversal, what you basically do is that first you traverse to the left node, then you do the operation. Once you return back from the left node, you do the operation on the root, then you go to the right node, and then you return, and you basically return whatever operation you did. And here in this case, you are supposed to enter the root value into a list, and at the end of the whole operation, that the in order traversal, you have to return the list itself. So let's write a helper for that. It takes self, then root, and then it takes a list. So if not root, then you just simply return. Otherwise, what you do is the self dot helper. You go to the sorry, you go to the right node. You go to the left node first with the nodes, whatever you have. Then you perform nodes the operation here, which is root dot var. Then at the end, you again, after you did the operation, you have to go to the right with the nodes. Yes, that's how it's supposed to. And here you can just simply call, I have to first write a node. That's the list going to return. And we will also have the nodes here. So that's how it is. So we'll call the helper function with the given root and the nodes, in which the help function will store the nodes. And now I will return the nodes. Yeah, all test cases passed, it will test. It's a simple one. Yes, 2ms. Let's go with the C++ one. It's simple, like it's a void function which takes tree nodes pointer as root, and vector int, that's the nodes, and if root, if not root, that basically a simple check for if the root exists in real life and abstract or not. Okay, and basically I just return. Otherwise, what I do is I call the helper with the root, with the left of the root, and with the nodes. And otherwise, in the second operation, I do nodes dot pushback, basically entering the root value to the nodes. And okay, again, I'm missing the semicolons here. Helper to root dot right and nodes. Okay, that's it. Here I have to call nodes, and I'll just call the helper with the root given and nodes, and let me just return nodes. It's a easy one, so it should work. Yes, it worked. In C++, things are very easy to write. I have been writing code in C++ for like the whole life. I started C++ from class 8, so it's pretty easy. Yeah, so that is it. But now let's go to the question that I have been anticipating to solve. The N-ary, where is the N-ary? I have completed these values. These are all logged. Hmm. I suppose I will have it. The question and I did PostOrder Traversal. In PostOrder Traversal, you know the root node is the operations on the root node are performed at the end after you have traversed from the left node and right node. Let's understand the problem. Given the root of an N-ary tree, return the pre or post-order traversal of its node's value. N-ary tree input serialization is represented in the level order traversal. Okay. Group of children is separated by the null values. Okay. 1, null 324, null 56. Okay. Hmm. So post-order traversal. Let me just check what the nodes have. Let's do it first in Python. Then we will move to, yes, the children's are optional list. Okay. Okay. So let's write another def helper. So basically, it will happen in the similar way as we have done in binary post-order traversal, binary tree post-order traversal. But in this case, we will have to run a loop for all the child nodes of its root. So the only difference here is that we have to put a loop here, nodes. Okay. If not root, then simply just return. Otherwise, uh, travel for child in children, root dot children, sorry, children, self dot helper, child node with nodes. And after you come back from the loop, that is, you have traversed all the route, you just have to simply nodes dot append the root value for that. Yes, that is it. I'll call nodes a list, and I will call the helper function with giving it its root to begin with and nodes, and then I will simply return the nodes. Yes, that's how it should be. Yes, let's submit it. Yeah, it is it. Let's go with C++ as well. But what is the structure? Okay, vector node. Yeah, it's vector node. So it's easy. Yeah, it's pretty easy. Let's just write void helper with node star root and vector int nodes. If not root, if not root, sorry, I'm sweating a bit. Sweating a bit. Just yeah. So I'm back again. So if it is not root, then I will just simply return. Otherwise, what I will do is I will like yeah, auto child and does it have children? Children. Call the helper node first with child and nodes. And after you come back from the loop, node start push back root 12. Okay, that's simple. Let's put a semicolon here. And here I will just simply vector int nodes. I call the helper and helper just with the root and nodes, and after the operation is completed, I will return nodes. Let's try another for auto child children. Okay, okay, this is root children. Yes. And I submitted it and think yes, bet 23%. Okay, is there any better way? Is there any better solution? We have also an N-ary Order Traversal, but that's for tomorrow. I'm not going to touch it today. Okay, let's see if it's the editorial. So this is in better code. They've used inbuilt stack, not the inbuilt stack, but saying user built stack. So okay, the same thing. Okay, the same thing. I'm using a loop. They are using a stack, uh, and no, they are also using a while loop. None better, I suppose. It's the same thing. Anyhow, you have to use a loop, whether it's a while loop or a for loop, you have to use it. So that's it for today. Please like, share, subscribe. I'm really feeling good recording this. So bye bye.